Welcome everyone, and thank you for joining this talk. In this talk, you will learn about how to get your machine learning workloads into Kubeflow. And if you're here, you probably already heard about Kubeflow, or you're planning to introduce machine learning into your current development. In today's agenda, I will cover machine learning operations today and machine learning engineers. How people can address these problems. I will cover a little bit about people organization. We'll talk about People 1.0 and we'll cover some of its major components. And of course, I will talk a little bit about our current people users. So let's get started. Do you remember these moments when you were driving in the car, or you had your morning run, or maybe you just were listening like music in your headphones, and suddenly your music providers help you with the song that you really, really love, and then you had this enjoyment moment. Or some other day, your bank send you a notification about something is going wrong with your bank account. Maybe it's like a fraud transaction and ask you to take some actions. So all this wouldn't be possible without machine learning. And machine learning, like almost everywhere, whether you're shopping online for food, for clothes, you use your voice assistants, like self-driving cars, like it's like in many, many places. And now you think about how can I implement the machine learning into my development? How can I make it easier for my users to get a better experience, to make some informed decisions? So how do I get there? So when people think about machine learning, they think about machine learning and how to write the proper code, how to like what kind of algorithm to choose, uh, what kind of framework to choose, and there are actually like so many frameworks around here, and like what language even, like is it in R, should it be in Python, and all of these are taken care of by data scientists. And data scientists, like their day-to-day job is exactly to figure out what kind of algorithm they want to use, what kind of parameters, how to improve the accuracy, how to improve efficiency. And so this is like the landscape of a daily job of a data scientist. But is it enough like to for having like a good machine learning in your company? So apparently, in order to implement and have good machine learning in your uh, current workflow, uh, you need to actually start with data. Because without the data, you can't build any model. Any model has data that you need to collect, you need to do data streaming, data storage, and you provide the access to the data to the data science. And this is what you usually take care of by data engineering team, and it's done by the data, big data, and so on. So now let's imagine that you have all these data. This is like where the machine learning development process started. Your like data scientists can take this data, start with some data exploration and analysis, do some data transformation, cleaning, trying to understand like what are features and like do some feature extraction. Then they need to again like try different algorithms to see like what fits best, to like find best parameters. And finally, when they came up with an idea like of how the model should look like, they need to proceed with training. Sometimes if it's like a big data, they do need to do some training at scale. And to do some training at scale, they need a platform that will support it and maybe some hardware accelerator. And all this should be done with some repeatable and consistent experimentation. But apart from this, like you can develop your model, but by the end of the day, what actually matters is that this model goes into production. And this is like where IT and data scientists sometimes too come into the place, into the picture. You take this serialized model, like with some artifacts, you build it, you put a version tag on top of it, and then you finally deploy it to your cluster with its cloud or premises, and do some inferencing, so all the traffic goes through your model. And of course, by the end of the day, you will always need to monitor for some failures, like for some biases, and so on. So this is a highly new space called machine learning operations. Why it's new? Because like machine learning and AI were like developing rapidly for the past decade, and we're mostly focused on the machine model accuracy and efficiency. But when people started implementing it into their current like industrial work, like industry workflow, they realized that there are so many steps to support it. And for this reason, they've been developing like many companies, like many different frameworks to support each of these steps. But the problem is that many of these frameworks were built separately, and they require like to have different documentation. So in order to combine these frameworks and to use all these pieces, you need to do some like integration between them. And what you usually expect is to have something like this, like to build this nice bridge between data scientists and IT operators, and maybe sometimes help data scientists do some machine learning operation stuff too. But in reality, what usually happens, you build something like this. So when you take all these pieces, and because most of the time it's just a job done by data scientists who actually want to spend more of his time to do some machine learning improvements rather than supporting the underlying infrastructure. So he tries to take all these pieces, integrate it somehow, and then of course this is like not too sufficient. Like first of all, the problem that data scientists stop spending like as much of his valuable time to build like actual model that can help the users, and at the same time he cannot spend enough time to support the good platform to uh, support his machine learning workflow. That's why we introduced Kubeflow, and Kubeflow is a machine learning open source cloud native platform on top of Kubernetes. And our mission is to make it easy for everyone to develop, deploy, and manage portable distributed machine learning on Kubernetes. So this platform, as I said, is open source. We received like more than 9,000 stars on GitHub, so it's very popular. Like more than 15 organizations currently contributing to the flow. And you can see the examples of the companies who contribute to the flow, like just portion of it on the right side. And we have more than 9,500 commits. The project like been running for 3 years, and it's still highly growing project as well as community. So why Kubeflow? Kubeflow is declarative, it's repeatable, cloud-native deployment that works anywhere where Kubernetes can be deployed. It's abstracted. Data scientists and machine learning engineers can spin up complicated deployments without knowing anything about infrastructure. I mean, ideally. And it is scalable. Complicated workflows and that are using Kubernetes, and all Kubernetes capacities are available for people. And here are some user testimonials. We received them as a part of our community user survey this spring. So one of the respondents left his comment that Kubeflow removed a lot of technical debt. A lot of companies, components they had to build and manage themselves in the past now are well integrated in Kubeflow. And the components that we're most excited about are pipelines and patches, and I will cover all these components a bit later. And another response that we got that they started using Kubeflow after 1.1 was released. They choose Kubeflow over other frameworks because in their POC they found it easier to use custom Docker images, and Kubernetes support was obviously good. They are Kubernetes company. So when I think about Kubeflow, that because it's built on top of Kubernetes, many of your engineers within DevOps who currently work with Kubernetes don't need to learn a lot about Kubeflow to support this platform, because everything that's used is used like for the Kubernetes APIs and all these CRD. And the same survey revealed some nice data. We have asked like Kubeflow and non-Kubeflow users uh, asked like the question, how long does it take to build one model, to develop one model from idea to production? And interestingly that on average, like for Kubeflow users, it takes from 1 to 3 months to build like and develop the model from idea to production, where for non-Kubeflow users, it might take from 6 up to a year, like from 6 months up to a year. So it's like a huge drastic difference between two sets of users. And Kubeflow available both on cloud and on premises because it's built on top of Kubernetes. Basically, wherever you can run Kubernetes, you can run Kubeflow, and it's as easy to deploy as using the kfile apply command, and you'll need to provide a YAML file for a particular cloud if you use some cloud vendors or for some on-premises deployment. Under the hood, Kubeflow, Kubernetes native, you can deploy all of applications on Kubernetes. It's multi-user, you can set up namespaces for multi-user isolation, and it's easily integrated with cloud infrastructure like identity providers, storage, IAM, etc. So this landscape is pushing us towards a loosely coupled microservice architecture that you can observe on the right-hand side. So whenever like a new library model service system is created, they need to be able to rapidly simulate into the flow. And we easily like integrated with some other external services like TF sorting, Fast, Zelda, and we come up with this microservice architecture because otherwise we won't be able to keep up with the growing landscape if we try to build a monolithic application. So we wanted to evolve all services. So now so all of these are as like huge flexibility in Kubeflow and as like you can customize and add your own components if you wish. So Kubeflow 1.0 was introduced this year, early this year, and it's a very exciting moment for all of our community because it's our first stable release. And sorry, something else. Okay, now, so Kubeflow 1.0 has some stable components such as Central Dashboard. Central Dashboard is a web UI that can give you easy access to all your Kubeflow components. Training operators, uh, these stable components provide you with some distributed or simple training on your machines. It doesn't matter like what kind of framework you use, but for 1.0, like the stable training operators are PyTorch and Kubeflow. Jupyter notebooks are very nice and popular tool for data scientists where they usually write the code and execute like all these code samples and can see like the results right away. And also from Jupyter notebooks you can spin up like all different Kubeflow components because Kubeflow provides this entity. And the next thing is profile controller. As I mentioned before, like Kubeflow provides multi-user isolation, and profile controller was meant to support. TF Cutter is our next stable component. Is a CLI tool to interact with Kubeflow tools. And besides stable components, Kubeflow released components that are still in beta. One of them called TF Serving is a nice abstraction layer on top of Knative to support quick deployments, serving on the machines like for machine learning models. Pipelines, I would say it's one of the most popular components. Although it's still in beta, people are heavily use it. It helps to orchestrate, it's an orchestration tool that build all these steps together. And all these steps are executable containers, and we can execute like in parallel or sequentially. Kadif is a hyperparameter tuning tool. Usually data scientists, when they build models, when they create models, they need to find best parameters to support the high accuracy and like less minimize like errors. So Kadif is here to find these parameters quickly. Pairing is a tool that comes into the place especially when it's really useful to do some hybrid machine learning. When data scientists want to do some deployments on the machine, and then pairing does the automated builds and put this machine learning model onto the server. And with the data component here to help collect all the artifacts from all these components, and these components can be integrated easily with the storage of each one. So the community realizes that repeatable workflows are important to efficient machine learning building. So we developed the core idea of Kubeflow 1.0 was to develop our core critical user journey that will support all these repeatable workflows starting from the develop, build, train, and deploy such as so this course UJ gives you the full picture of machine learning for data science. And let's dive into each of these steps. So first of the step is the develop step, and we provide Jupyter notebooks. Jupyter notebooks, as I said, is like a very popular web UI IDE where data scientists can interact with its code. And to showcase the profile controller feature, I will show you some example. Like we have a data scientist Bob who has access to his own box namespace, and he created different notebooks and different experimentation, and only he can see his code here. And we have a data scientist Liz. She also got the namespace, which you also can develop and interact with your machine learning code and data. So all the data can be isolated for both and leads, especially if they are not supposed to see some maybe high secure like privacy data. But what if both and leads want to develop the machine learning together? Now they can have their access to the shared namespace, and they can see with each other's notebooks as well as to work on the same notebook together. So when machine learning code is developed, now your data scientist can automate build from the local machine, put it into the Docker container, and so it's actually pairing all does it automatically. So what all the data scientist is need to do, he needs to just use the pairing library, and I'll show it a bit later. And with this library will build an image for him, and will put into the server, remote server, whether it's cloud or your on-premise server. And data scientists can see the results back. So this is an example of just 3 lines of code, how you can automate these builds. And once these builds are available on your remote machine, you can use training operators and such as TensorFlow or PyTorch operator, and some operators that are still in beta such as XGBoost or NextNet. And we have other operators available. You can look on our website. So these training operators provide for data scientists a faster training to distribute the jobs, faster iteration and automated workflows for subsequent iteration, and as well as faster validation and high quality models. So it helps to do some distributed training with a single run, or distributed on multi-CPU or GPUs, or maybe even without GPUs. And for IT operators, it really helps to support declarative and containerized operations. It gives better utilization of the infrastructure and simplified management of distributed jobs. And lastly, when you or your data scientist finally were able to train the model, This is the last step where you want to put this model into production, and TF storing comes into the picture. So TF storing, as I said, is a layer abstraction on top of Knative. Uh, and Knative is a serverless platform to support scalable deployment. The nice thing of TF storing because with this a very easy and simple interface that we meant to develop, especially like for data scientists who are not that proficient with infrastructure. That it abstracts all this complexity, and what all we need to do is to define the this like simple configuration file and a very framework agnostic. So it doesn't matter what kind of framework when you Kubeflow, it's fine, we want to use Python and so on. So all what you need to do is to set up this configuration file to show only the framework that you use. Here is like scikit-learn, for instance, or TensorFlow, or PyTorch, and then you need to point uh, to the place where your trained model is stored. And on the day one is as easy as this. But what if like later on you want to add some extra complexity for your deployment? You can always come back to this configuration file and add some advanced options. And there are some components that are in beta, but still very important and popular. So such of them is hyperparameter tuning. It's called fatigue. So fatigue helps your data scientists uh, to either train the model, multiple models with different hyperparameters. It provides various algorithms such as word Bayesian optimization or hyperbrand to efficiently search the space. And the space you can set up here, like is a bound like from the minimum and maximum the number of the parameters you wanna use. And you need to set up the objective is like what you wanna like minimize. This objective metric uh, is like it can be like model accuracy or it can be like error like in this case. So and we had like really nice examples when this hyperparameter tuning was able to actually improve the Kaggle model winner like by 20%, which is like really awesome. You can find these examples online on the web. We have many recordings for this if you're interested to learn how it was done. And finally, the most popular component is the pipeline. Uh, it helps to define complex parameterized pipelines using Python. Uh, you can see the example of it here. And containers, it connects all the containers, and this provides adaptability, repeatability, and encapsulation. So a task can be single mode or distributed. So it's a really, really great tool that helps you to see the full picture of the machine learning workflow. And finally, this is like what our Kubeflow users reported. Uh, we were happy to see that more than 60 and almost 70% of our Kubeflow users uh, said that it became easier for them to manage machine learning infrastructure at scale, and more than 50% speed up the development and delivery, and 50% said that now they have better control of machine learning workloads instead. Thank you. This is all what I wanted to say today. If you want to learn more, you can visit our Kubeflow.org website. You can also join our discussion mailer. We always welcome new contributors, and you can find the contributing guide on our website. And some of the demo code that I showed in the slides are available at our Cisco repository, Cisco AI, Cisco Kubeflow Starter. And if you have any questions left, please email me, and you can see my email here. So, this is it. Thank you.